Okay, in the previous video, we showed you how to graph this function on this interval. So let's say that, hey, here we have this function, right? But now, let us go a step further. Let us go a step further and say, after we graph, let us say then, hence, right? So now that you've graphed it, hence, solve f of x is equal to 0, right? So if we have our graph, f of x is equal to 0 is going to be these 4 points, those 4 points on the x-axis where I cross. Now, if I want to solve, really that's just saying I'm going to set 2 cosine of x minus 1 equal to 0. All right, what could I do next? Well, I could add 1 to both sides, and that's going to give me 2 cosine of x is equal to 1. Divide both sides by 2, and I have cosine of x is equal to 1/2, right? Now, if I think about my quadrants, and I think about when is my cosine equal to 1/2, I know that my cosine of x is equal to 1/2 in the first quadrant, but also symmetrically, my cosine of x will be positive 1/2 in that fourth quadrant. Correct? So I can think about this as at x equals pi over 3 will be for quadrant 1, and at x equals 5 pi over 3, right? 5 pi over 3 for quadrant 4, because I know that my reference angle, right, whether I go up this way or I go down that way, I know that my reference angle is pi over 3 because I understand that the cosine of pi over 3 is equal to 1/2. Right, so I have 2 solutions here. Right, I have my quadrant 1, quadrant 4, that if I look at this, this would relate to this solution and that solution, right? But if I look on here, I have 2 more solutions. Well, how do I find these other solutions? We got to understand that we have the distance from there to there, right? The time that it takes to repeat is our period, right? So if I take x equals pi over 3 and I add the period, which in this case is 2 pi, then that's going to give me my next solution, right? And pi over 3 plus 2 pi is equivalent to pi over 3 plus 6 pi over 3, right? And so I can say that x equals 7 pi over 3 is another solution, all right? Now, this solution is our 5 pi over 3, right? And if I think about the distance from that solution over to our next solution, right, that distance is also represented by our period, right? So then we can say, hey, x equals 5 pi over 3 plus the period, which would be 6 pi over 3, right? And if I look at this, right, 5 pi over 3 plus 6 pi over 3 is going to be equal to 11 pi over 3, which would represent this fourth solution on this interval. All right, so we have x equals 11 pi over 3. So if we have our graph, we can determine solutions to equations with a little bit more certainty. Or if we're familiar with the graph, we can know how many solutions we have. Because in this situation, we have 1, 2, 3, 4 solutions, and those 4 solutions would be the 4 solutions that we determined. All right? This takes practice, but you will get better.